Good afternoon, level twos. After our fun and games today, we didn't get to have our lesson and we're falling behind. So this is particularly for line 1 in period 5 today. So we looked at concave mirrors the last time you came to class. We looked at what do they look like, and remember that C, or the center of curvature, is also called the focal center, I think, and it's double the focal length. We also looked at the 2 rules for reflection of concave mirrors. And any incident ray that travels parallel, that's this one, the blue ray, will come out or be reflected away from the mirror and go through the focal point. And if a ray travels through the focal point, it will come out or be reflected by the mirror and then travel parallel to the principal axis. So you've got that written down. We went through this drawing of the first example very carefully together already. So we draw 2 lines from the top of the object. So that purple line on the left here, that's the object. We draw those 2 lines, and using those same rules, we draw the reflected rays according to the 2 rules. Remember to put arrows on them, and where they meet, that is where your image is going to be. So that's the first example. So we're ready to move on now. We have to explain that the image is real, inverted, and diminished. So real, because it's on the same side as the object. This is the image. It's inverted. You can see this one's going upright and this one's upside down, and it's smaller. It's diminished. So double check that you can explain the laws of reflection, and we're going to continue drawing ray diagrams. Right, so this is the purpose of drawing a ray diagram. It's to explain what type of image is formed. Is the image real or virtual? Is it upright or inverted, and is it diminished or enlarged? You only need to do scale drawing if you need to measure the size or position of the image. Otherwise, we can use Descartes' formula. All right, so this is the first one. So what you need to draw first is the blue line at the top here. Draw it parallel to the principal axis and then reflect it through the focal point down to the bottom here. The second line you draw is from the top of the object. Remember, 2 from the top of the object through the focal point to the mirror and along the bottom parallel to the principal axis. You will then find where these 2 rays meet, you're going to have a top of the image. So you put an arrow at that point and you draw down from the principal axis. So that will give you the image. And you can see you need to have 3 things here to say about this image. So the image is real. It is a real image. It is upside down or inverted, and it is enlarged. It's larger than the actual object. Only a little bit, but still. Next one you have to do, and you have to know, is when the object is at the center of curvature, or at 2f, so double the focal length, then you do the same thing and you see that the image is inverted or upside down. It's about the same size, if not exactly the same size as the object, and it is a real image as well. It's also on the same side as the object. Next one. Here you've got the object beyond C, and you can see that the image that is produced is real. It's upside down or inverted, and it is smaller. It is diminished. Okay, for this one, you can see that when the object is at F, the focal point, there is no image. The reason is because these rays are parallel, so they never meet, which means there's no focus. There's no image formed. And this is an example of when you took the curved mirror, the concave mirror, and you moved it away from your eye to approximately the focal length of the mirror. It was very blurry. You couldn't see anything. Right? No image is formed. For real objects between F, this is when you held the concave mirror close to your eye, and you saw that whatever you were looking at, which was your eye in this case, was really large, okay, and you were actually seeing a virtual image. So let's go through how to draw this. The real object, darker blue ray goes through to the mirror, reflects back through F, and then this blue ray, you probably haven't seen one like this before, but basically it goes to the mirror and then reflects away. And the angle inside, which is in this case is the normal along the principal axis, is equal to the angle at the bottom end of that principal axis. So these two angles are equal. And then you subtend, there's a dotted line with no arrows on it. You subtend both of them back behind the mirror, and where they meet, that is where your virtual image is. And you can see the virtual image is enlarged. It's behind the mirror, and it's upright. It's not upside down. So those are the three things you'd mention there. You can also draw it like this. Your textbook does it like this. So again, this time goes to and then reflects through, but look at the second one. It's the same thing. You can get the same diagram. Okay. You need to complete activity 6B, questions 1, 2, and 5. And then also, this is the one that's in your textbook. Sorry, I got confused there. Just go back. So if you look at the dotted green line, what they've done is drawn an arrow that goes from the focal point, or rather a line that goes from the focal point past the tip of the object all the way to the mirror, and then it reflects parallel up to the principal axis. Obviously that one needs to be subtended then to the back. So all three of those lines will give you the same position. Also finished question 7A from 6B, and then we have done Descartes' formula in the last lesson already. So you'll be up to date. Well done.